This is a Middle Loop quick class.
Hi, I'm Jerry with Middle Loop, and in this quick class, we show how to create that iconic Eclipse photo perfectly aligned and evenly spaced. So you bought a solar filter for your camera and spent the day taking photos of the solar eclipse. Now what? Well, you could create a time-lapse for social media, or maybe just a single print of Totality. But if you're looking to produce that composite photo of the entire event, this quick class is for you. In order to jump right into the main objective of this quick class, we're going to assume that you've already completed any post-processing of your images, like rotation, exposure, and saturation. You should also have finalized the photo that you'll be using for the center totality shot. We provided a link to other videos in the description that can help you with all of that. We'll start out with calculating the size of the final compilation. In order to do that, we'll first have to figure out how much space to put between the images. Then we'll get into it. We'll show how to align the images in a straight line and how to get the spacing between the images exactly right. Then at the end, we'll cover a couple of ancillary topics that we referenced throughout. We'll show a method for getting that middle totality photo in the exact center. And we'll also show how to build a simple spreadsheet that helps with the placement and spacing of the photos. Now, let's get started. In today's video, we'll be using Photoshop. However, this video is more about the process than the product. And since most photo editing software has similar functionality, you should be able to translate most of this method for use with your favorites. We'll be calculating two measurements here. The first is the spacing we'll use between images, and the second is the overall image size. All of our measurements will be in pixels. Before we start with the calculations, you'll need to know how many images you'll be using for your final compilation. Of course, this will be an odd number, with totality in the middle and an even number of images on either side. In our case, we'll be using 15 total images. That's 7 before and 7 after. We first tried 29 images, but that was way too many, so we cut it in half. To be as symmetrical as possible, it's fairly important to use images that were taken an equal amount of time apart. Where I captured the event, in Vermont, the partial eclipse before and after totality lasted about 70 minutes. And since we're using 7 photos for each, the math was pretty easy. We're using photos that were taken about 10 minutes apart. The first shot in our sequence is the photo taken just before first contact, or C1, while the sun was still full. Likewise, the image we used for the last photo was taken right after the eclipse ended. Then, working towards the center, this photo was taken 10 minutes after the first one, and this photo was taken 10 minutes before the last. Continue inward until you've selected all of your images. Now that we've set aside our photos, let's calculate the total size of the compilation. For this, we'll be using the totality photo as a reference. The height of the compilation is easy. We'll simply use the height of this image, which in our case is 5006 pixels. In order to calculate the total width, we need to know how much space to put between each image. A good reference to use for that, we find, is to measure the space from the leftmost edge of the sun to the right edge of the corona. Not the extreme fringes of the corona, just the most visible parts. To take that measurement, we'll use the ruler feature found on most photo editors. In Photoshop, you can turn rulers on with the shortcut Ctrl-R on a PC or Command-R on a Mac. Also, make sure it's set to pixels, which you can change with a right-click on the ruler. Now, you have lots of options to take this measurement. In Photoshop, I like to use the rectangular select tool. Just left-click and drag. And there you have it. We'll be using 1687 pixels for the space between images. Another method you could use to measure this is to drag guides onto your image, and then subtract the two locations. Either way, now that we know the space between the photos, it's simple math to get the total width of our compilation. Just take the total number of images, in our case 15, add 1 to it, which gets us to 16, then multiply that number by the space we just measured between images. And now we have the dimensions of our final compilation, 26991 by 5006 pixels. Now that we know the dimensions of our final compilation, go ahead and create a new image by those dimensions and add all 15 photos into it as layers. We'll assume you know how to do that in your favorite software. In Photoshop, there are a number of ways to do this. We used the Load Files into Stack feature. And here you can see we have all of our photos as separate layers. And in our case, they came in alphabetical order, which for us also happens to be chronological order, making it easy to keep track of the order that they'll be placed in our compilation. If yours aren't in the right order, you might want to take the time to rearrange them. And you might also consider renaming the layers if your layer names aren't clear. Okay, so ours aren't quite chronological. This is where Totality ended up, which is fine. I actually prefer it near the bottom. You might also have noticed this layer right below it. This is a completely black layer. In our case, it was added automatically when we created the image. This layer is useful if you end up with any gaps between your images. If you don't have one, you might want to add a solid black layer all the way to the bottom. Now, the first thing we need to do to get our photos aligned is to center our Totality photo. Let's start by turning off the visibility of all the layers except Totality and the one below it. In Photoshop, you can simply click and drag down on the visibility icon. Again, we'll be using rulers and guides to center the image, so make sure they're turned on. Incidentally, by default, the 0 point of the ruler should already be set to the left edge of your image. If yours is not, just double-click in the square between the horizontal and vertical rulers to reset it. Now, let's change the ruler from pixels to percent. Right-click on the ruler, and you guessed it, select percent. Now, under the View menu, select Guides, and then New Guide. In the Position field, type 50 and press Enter. Let's do it again, only this time we'll change the orientation to horizontal. Now we have a crosshair in the exact middle of the compilation. And as you can see, our Totality image is not in the center. Let's zoom in and move it. Click on the Totality layer and then select the Move tool. Now click on and drag the sun to as close to the center as you can get it. Okay, that looks pretty good, which is probably good enough. However, if you want to take the time to put it in the exact center, we show a method for that at the end of this quick class. Now that we have Totality centered, we'll be aligning all of the other images to it. To do that, we'll be placing all of the other photos centered exactly on top of this one, and then move them horizontally into place. And to make that a little easier, let's first roughly center them. Again, make sure the Move tool is selected, and now let's select the first layer and make it visible. So that we can see both layers at once, let's change the blending method to Lighten. If your photo editor doesn't have this feature, you could use opacity and change it to something like 50%. The goal here is to be able to see both images at once. Now let's drag and drop the layer so that the sun roughly aligns with the Totality layer. Again, it doesn't need to be perfect. We'll be getting it much more precise a little later. Okay, that looks good. Let's turn the visibility off for this layer and repeat for all the other layers. Now that we have all of our images roughly centered and on top of each other, it's time to place them exactly where we want them. This grid shows what we're looking for. Each image is vertically in line with Totality. Horizontally, they're each offset from each other by 1687 pixels. And if you remember, 1687 is the distance we measured earlier to use as the space between images. So the center of this image is 1687 pixels to the right of Totality. And the next image is 3,374 pixels to the right of Totality. That's 1687 times 2. This one is 3 times the offset, and so forth. So on the right side of Totality, the offset is added, but on the left side, the offset is subtracted. So our process for the final placement will be to take one image at a time, fine-tune it so it's exactly sitting on top of Totality, and then move it left or right by the exact number of pixels. Now the math here is pretty simple, and to make it even easier, we'll be using a simple spreadsheet to assist with our calculations. If you're interested, we'll show you how to build the spreadsheet at the end of this quick class. Let's double-check the ruler. For this next step, we want to make sure that it's set to pixels. Right-click on it and change it if it's not. So right now, the only 2 visible layers are Totality and the black layer right below it. Totality is still locked, and we have the Move tool selected. Let's go ahead and zoom in so Totality pretty much fills up your screen. Now you don't have to move the images in any particular order. We'll be starting with the photo that goes just to the right of Totality. We'll first make it visible and then select it. As a reminder, we still have the blending option set to lighten so you can see both images at once. Now go ahead and move the layer so it aligns exactly with Totality. In this case, it's already pretty close, so we're going to nudge it into place using the arrow keys. If interested, we explain the nudge feature in more detail at the end when we go over fine-tuning Totality. Okay, I'm pretty happy with that. Now that we have it exactly aligned with Totality, let's move it into its final position. Vertically, it's already aligned, so all we have to do now is move it horizontally. Up here, you can see that the x-coordinate of this layer is sitting at 10,994. To move it, we simply need to take that number, add 1687 to it, and type in the new number. This is where that spreadsheet we mentioned earlier comes in. First, we're going to highlight and copy this number to the clipboard. Now let's jump over to our spreadsheet and paste it into the current column of the image we're moving. Okay, that gives us the value of the new location. Let's copy it to the clipboard, then flip back over to the image and paste it into the x-coordinate. And now if we zoom out, you can see that it's been moved to the right position. And now if you want, you can lock the layer so you don't move it accidentally. Just remember, if you're not using our spreadsheet, when moving the second image to the right of totality, you need to double the offset, triple it for the third, and so on. Plus, for the images to the left of totality, you're subtracting the offset, not adding it. And that's it. Just repeat this for the remaining images. And there you have it, that iconic solar eclipse compilation. Now you just need to export it and you're all set. As we mentioned when we were centering the totality image by eye, here's the method you can use to fine-tune it so it's in the exact center. This method assumes you already have it pretty close and that you already have the rulers turned on. For this, we want the ruler set to pixels. If not already set, right-click on the ruler and switch it. Now, let's drag 4 more guides onto the image, 2 horizontal and 2 vertical, roughly aligned with the edge of the sun. Then zoom in and drag the guides we just added to as close to the actual edge of the sun as you can get it. Use whole pixels, don't bother with fractions. And once in place, be sure to note the location of each guide. Do that for all 4. Also, while you're zoomed in, write down the location of the center guides, both the vertical and horizontal. Now that we've done all of that, we can calculate how far off from center we are. We know the distance between the two is 607 pixels. And if we subtract the center horizontal from the top line, that distance is 576. So that means the bottom of the sun is a little further from the center than the top. And if we subtract the two, we get a difference of 31 pixels. Dividing that by 2 tells us we need to move the sun up by 15 pixels. Doing the same for the left and right, we know that we need to move the photo to the left by 4 pixels. So to move the totality photo, in Photoshop we'll use the nudge feature. Nudging moves the layer in one direction or another by a set number of pixels. Make sure the layer and the move tool are selected. Then simply use the arrow keys. If you look at the properties window, you can see it in action. We need to move the totality layer 4 pixels to the left, so I'm going to tap the left arrow 4 times. I should note that the actual number of pixels that the layer moves every time you tap the arrow key depends on the zoom level. In my case, I'm zoomed in pretty far, so mine only moves 1 pixel every time I tap the arrow key. By the way, instead of using the nudge feature, you could just simply type in the value you want here if you know it. Now I'll nudge the photo up 15 pixels, and that's it. Our totality photo is exactly centered, and since we don't need the guides anymore, we can turn them off. Also, let's go ahead and lock the layer so we don't accidentally move it. Lock the layer by simply tapping on the lock icon with the layer selected. Let's create a quick spreadsheet that'll help us to calculate the horizontal position of each of our layers. We're using Excel. This is the first image on the far left, all the way to the last image on the far right, with totality being right in the middle. The offset column will be the number of pixels each image needs to move. We'll fill this in a moment. The current column will be the starting horizontal location of the layer once we have it placed exactly on top of totality. And the new column is the location that we'll be moving the image to. This value will be calculated for us. Now, since totality is our reference point, its offset is 0, so we'll just type that in. For the image that's just to the right of totality, the offset is 1687. I'm sure you'll remember that that's the measurement we took at the very beginning for our space between images. We could just type it in, but instead, it'll be easier to use a simple formula. Click in the offset field and type an equal sign. Then click in the offset field just above it. Type a plus sign, and then type in 1687 and press enter. So now, this field is equal to the field just above it plus 1687. And now we just need to duplicate the formula all the way down. To do that, just tap in the field with the formula we just created. Now click on that little square in the bottom right and drag it all the way down to the last image and release it. And now we have the offsets for all the images on the right side of our compilation. Now we'll do the same for the images to the left of Totality, only this time we'll be subtracting the space instead of adding it. To finish up our spreadsheet, we want to calculate the new column. For this, another quick formula. Click in the New field of the first image. Again, type in an equal sign. Now click the Offset field of the image, type a plus sign, click the Current field, and press Enter. And that's the formula that will calculate the location of the first image. Now let's duplicate it for all the other images. Click back in the field we just created the formula in, and like before, grab that little square and drag it all the way down. Perfect! Our spreadsheet is now complete. So that's it for this quick class. I hope it helps getting all of your solar eclipse images perfectly aligned and spaced. If you found this video useful, don't forget to subscribe and tap that like button. Have a great day, and thanks for watching.